Hi ma'am, this is M. Prudviraj from ECD section. Today I want to calculate V naught by dot polarity. The outline of the PPT is dot convention, classification of coupling, electrical coupling, magnetic coupling, equations and calculating V naught by following the methods. Dot convention. Dot convention is a technique which gives the details about voltage polarity at the dotted terminal. This information is useful while writing KVL equations. If the current enters at the dotted terminal of one coil or inductor, then it induces a voltage at another coil or inductor, which is having positive polarity at the dotted terminal. If the current leaves from the dotted terminal of one coil or inductor, then it induces a voltage at another coil or inductor which is having negative polarity at the dotted terminal. Classification of coupling. You can classify coupling into the following two categories: electrical coupling and magnetic coupling. Now let us discuss about each type of coupling one by one. Electrical coupling. Electrical coupling occurs when there exists a physical connection between two coils or inductors. This coupling can be of either adding type or opposing type. It is based on whether the current enters at the dotted terminal or leaves from the dotted terminal. Magnetic coupling. Magnetic coupling occurs when there is no physical connection between two coils or inductors. This coupling can be of either aiding type or opposing type. It is based on whether the current enters at the dotted terminal or leaves from the dotted terminals. Applying KVL around primary coil. V1 minus L1 di1 by dt minus M di2 by dt equal to 0. V1 equal to L1 di1 by dt plus M di2 by dt. It is the equation 1. Apply KVL around secondary coil. V2 minus L2 di2 by dt minus M di1 by dt equal to 0. V2 equal to L2 into di2 by dt plus M into di1 by dt. It is the equation 2. Applying KVL around primary coil, then we get V1 minus L1 into di1 by dt plus M into di2 by dt equal to 0. V1 equal to L1 into di1 by dt minus M into di2 by dt. It is the equation 3. V1 equal to L1 into di1 by dt minus M into di2 by dt. It is the equation 3. Apply KVL around secondary coil. V2 minus L2 into di2 by dt plus M into di1 by dt. V2 equal to L2 into di2 by dt minus M into di1 by dt. It is the equation 4. It is the given circuit in which we have resistance of 2 ohms, J6 ohms, J1 ohm and dot polarity, J4 ohm, 1 ohm minus J1 ohm, V0 1 ohm, 12 angle of 0 degrees. In this we have to determine the V0 in the circuit. In this first one, the current is flowing is named as I1 and this second one is named as I2. From this we can draw the following figures in which L1, L2 following the positive and negatives. From those we can draw the circuits in the below where 12 degrees 0 degree, 2 ohms, J4 ohms, J I2 bar, J1 bar, J4 ohm, 1 ohm. From these circuits we can conclude that minus 12 plus 2 plus J6 into I1 bar plus J into I2 bar equal to 0. 12 equal to 2 plus J6 into I1 bar plus J into I2 bar. It is the equation 1. I1 bar plus 14 plus 1 minus 1 plus 1 into I2 bar equal to 0. I1 bar equal to minus 2 into 2 plus 3J by J into I2 bar. That is equal to J square into 2 plus 3J by J into I2 bar. that is equal to minus 3 plus 2j into I2 bar. 12 equal to I j I2 bar plus 2 plus j6 into minus 3 plus 2j into I2 bar, that is equal to j minus 6 plus 4j minus j 18 minus 12 into I2 bar. I2 equal to 12 by minus 18 minus j 13, that is equal to 12 by 22 minus 203 angle minus 144 minus 0.16. V0 equal to I2 bar. V0 equal to 0.54046 angle plus 144.16 volts, that is equal to V0 equal to 540.46 angle plus 414416 m voltage J1 ohm. It is the final V0 from the given circuit. Thank you, ma'am. Thank you for giving this opportunity.